So today we're going to be working on understanding and solving two-step algebra equations. Last week we reviewed one-step equations using division and or addition and subtraction. So we're going to review those first, and then we're going to start moving on to learning how to do two-step equations. Our learning goal is going to be understanding and solving two-step algebra equations. So we're going to start with a review of our single-step equations. On our left side, we have an example that uses addition to solve it, and on the right side, we have an equation that uses division. So we're going to start on the left. You see our equation is x minus 5 equals 1. So if we remember, we want to isolate the x on one side of the equation, and to do that, we're going to add 5 to both sides, so the minus 5 and the plus 5 cancel each other out, and then on the right side of the equation we're going to add that 5 to the 1 to get our answer of x equals 6. And then we're going to move over to the right side of the slide where our equation is 3x equals 9. Now what we need to do here to isolate the x is we need to divide both sides of the equation by 3 because it's 3x on the left. Luckily, 9 is divisible by 3, so we're just going to divide each side by 3. The 3x and the 3 are going to cancel out to just x, and then 9 divided by 3 does equal 3. Alright, we are going to move on. One thing before we start actually solving two-step algebra equations is we want to make sure we all are familiar with the acronym PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction as our order of operations when solving equations. For two-step algebra equations, though, we need to inverse the operations. So we're actually going to subtract, then add, then divide, then multiply, then use exponents, and use parentheses for these problems. So just make sure we are always subtracting or adding, then dividing or multiplying. Alright, so I'm going to show you a model of how we can learn to solve two-step algebra equations. If you remember, in the past we've used rods to signify our x, and we've used the cubes to signify our single digits or double digits, just our constants. There we go. So this equation is 3x plus 9 plus 12. So we have 3 rods on the left, 9 cubes on the left, and 12 cubes on the right. So if we remember, we always want to isolate our x. That's how we're going to solve these equations. And if you remember on the last slide, we were talking about how we're looking at our PEMDAS, order of operations, and we're going to start from the right and move to the left. So if we remember, our first step of order of operations would be subtraction, then addition. So what we're going to want to do is we're going to want to subtract 9 from both sides to start isolating that x. So here's an example of that. Those red cubes signify the 9 cubes that we're going to be subtracting from both sides. So if you see, now we only have 3 rods and we only have 3 cubes because we subtracted 9 from both sides and they cancel out. So now we're going to be left with 3x equals 1, 2, 3 because we only have 3 of those cubes remaining on the right, and we're going to want to divide them. So this is how I modeled us dividing 3x equals 3, which you can see on the top. So we divided each side by 3, so that's why we have the 3 rods on the left, the 3 cubes on the right, and when you divide 3x by 3, you get a single x, and when you divide 3 by 3, you get 1. So our answer is going to be x equals 1. And then we're going to do one more. So this one's going to be subtracting 8. So we're going to have 4x minus 8 equals 12. That's why this time the cubes are red instead of yellow. So to cancel them out, what do you think we have to do? Yep, we're going to add 8 to both sides, because if we subtracted 8 from both sides, it would go from 4x minus 8 to 4x minus 16. If we add 8, those 8's are going to cancel out, and we're going to add 8 to our 12, which is going to look like this. So we added 8 yellow cubes on the left, and we wanted to just show that we were adding 8 on the right, so I made it green instead of yellow this time because they're positive. And then those are going to cancel out on the left, because when you add 8 to a negative 8, that will equal out to 0. And if you count really carefully, we now have 20 cubes on the right, because 12 plus 8 is 20. And now, as before, we are going to divide. So you can see, since we added 8 on both sides, our new equation looks like x equals 20. And then we're going to divide up our rods and our cubes. And when you divide 4x by 4, you get just x, and 20 divided by 4 equals 5. All right. So our final thing that we're going to do is I'm going to have you try some equations on your own. Our first one is going to be 5x plus 5 equals 15. So if we remember PEMDAS, make sure we start with subtracting from both sides, and then you're going to divide. Same thing with example 2. You're going to subtract from both sides, so you're going to subtract that 6, and then you're going to divide that 2. So I'll give you a second to work on these problems, and then I will give you a chance to answer. All right, now that you had some time to work on it and put your answer in on Edpuzzle, our answer for number 1, is x equals 2, because we subtracted 5 from both sides, so we're left with 5x equals 10. We divide then both sides by 5, so 5x divided by 5 equals just x, and then 10 divided by 5 equals 2, so x equals 2. And then for example 2, we got x equals 3, because we are going to subtract 6 from both sides, which leaves us with 2x equals 6, and then we're going to divide both sides by 2. 2x divided by 2 equals just x, and 6 divided by 2 equals 3. And that is going to be it for today. Great job. I hope you have a good weekend. Stay safe, and I will see you next time. Bye, guys.